Hello, everybody. My name is Manuel Minteguiaga. I am from Uruguay. It is my pleasure to be here with you to share my presentation. I want to thank you, the organizing committee, for inviting me to be part of this important online conference on traditional medicine. I think that it's very important to have here this opportunity to share our knowledge all around the world. So I will share my screen with you to initiate my presentation. Okay, here we are. Okay, just a minute. Like here. Okay, perfect. My work is entitled Plant Extracts and Essential Oil from the Southern Cone of South America. Potential has neutralized of snake venoms at in vitro condition. This work was performed mainly in the University of the Republic in Uruguay, also in the National University of Tucumán in Argentina, and also in the National University of Northeastern, also in Argentina. Okay. For initiating my presentation, I have to say that in 2017, the World Health Organization declared the snake bite envenoming as a neglected tropical disease and published this strategy for prevention and control of this issue. This is very worrisome because snake venom can precipitate a multi-organ failure or multi-system disease, for example, affecting heart, affecting kidneys, affecting also the lungs, affecting the liver, muscles, and at the end, in extreme cases, the introduction of the venom on our system can precipitate the death of the person that is affected by the snake bite. Here you have a map of the world. Here is the region more affected. Asia accounts for 2 million people in venoming every year, with around 100,000 deaths every year. The second most affected area is Africa, and in Latin America accounts for 150,000 envenomings every year and around 5,000 deaths. Okay, here we have this is Uruguay, this is Argentina, this is the southern cone of South America. So we are in the center of one of the most problematic regions for the snake bite envenoming. What about the use or the tradition, better, the tradition of snakes in South American culture? Probably you know about the Incas. The Incas culture, here is a sculpture of an Inca that here is a snake, okay? These snakes were sacred animals for Incas, a symbol of wisdom and in the infinite, and were considered the connection between the underworld and the terrestrial world. Okay, in some cases was represented by earthquakes. Okay, in the other hand, we have in the regions of South America a strong tradition on the use of medicinal plants to treat the snake bite envenoming. For example, in the way on the form of ointment to be applied directly on the region affected by the snake bite. Here you have a map of the alexitheric plants, the presence of alexitheric plants. What about alexitheric plants? These are medicinal plants that are useful to treat the effects of the snake venom, to neutralize the deleterious effects of the snake venom. Okay, these plants are present mainly in the tropical and subtropical regions, for example, in Asia, in Africa, and in South America, are associated with the richness of the flora, and also these plants are used by the indigenous people for treating this problem. Because the availability of the conventional treatment for for envenoming, for example, the use of serum is not always possible in these countries. Okay, Also, the plants, part of the plants more employed for the treatment are leaves and roots. Applied directly on topical applications of this product on the place of the bite. Here you have an graphics of 71% of the species of allergic cherry plants are present in Asia, 23% in South America, in America, mainly South America. Okay, but here you have our country, Uruguay and Argentina, the information about plants used against the snake bite envenoming is almost absent. What about the effects of the plants compounds against the snake bites, the snake venom? For example, plants have specialized or secondary metabolites that are present in all the organs that can contribute to the inhibition of the effects of the venom. For example, through physical interactions, through chelation of metal ions of the venom, to antioxidant activity, anti-inflammatory properties, or immunomodulation. And the most important is the enzyme inhibition, for example, because the snake venom is composed mainly of enzymes, for example, phospholipases and also proteinases that are inhibited by the compounds present in the plants. What is our approach? Well, so our approach has two arms. On this, in one side, we have the ophidian accidents. We have the public health problem that is very worrisome for the public systems. Okay, yeah, here you have, for example, two venomous species of Botrop genus. This is the problem. And the other side, we have the opportunity, the use of allergic plants with non medicinal use or a scientific citation about use in other regions of the continent or in other region of the world. Okay, but not scientifically validated in our conditions. So in the southern cone, South America. We proceed to this scheme that is the verification of the electric activity, both in vitro and in vivo condition, and through the isolation of the active components or identification of the most active extract for isolating the compounds responsible for the action. Our vision is to treat this problem through phytotherapy, but we are realistic and we know that it's not possible always to treat this problem only with the with plants. So this is eventually complementary medicine with the traditional or the more frequent treatment that is antiophidic serum. Here we have the problem. Here is the species Bothrop giporus. Bothrop family Viperidae in South America has more than 48 venomous species, are responsible for more than 90% of the Fidian cases in our region. The more affected people in general are rural workers and children. So this is very worrisome. Okay, here you have pictures about the effects of the venom. The venom has a systemic effects, severe effects, including death, but also proteolytic and procoagulant effect that causes, for example, edema or necrosis or hemorrhage. Okay, and in some cases, it conducts to the amputation of the member, so amputation of the arm or the leg. So it's very problematic. Okay, anti-ophidian serum, that is the conventional treatment for snake bite envenoming, is not always effective, and it is useless against local effects. So these effects are not possible to be neutralized by anti-ophidian serum. In Argentina, 90-70% of the cases are produced by Botrus diporus, this one, and Botrus alternatus. This species only is responsible for more than 80% of the cases, so it's very complicated for the public health system. What about the plant? Okay, at the first, in our work, At the first stage, we studied this species named Bacillus trimerans, and the common name is Cargesia. Here is a picture of the plants. Okay, what it was a previous scientific evidence of the properties of these plants against venom. This is a publication of 2004. This is a medicinal species broadly distributed in Argentina and Uruguay. Okay, we proceed through extraction of the essential oil. This is the essential oil, yellowish essential oil, in a pilot unit of steam distillation. Here is the plant, here is the unit. Okay, we fractionate the essential oil through liquid chromatography, and after we perform GCMS, so gas chromatography, mass spectrometry analysis. At the end, we identified 150 compounds, 79 of them not previously reported. Among the compounds identified, we obtained these ones. Okay, this is our name irregular monoterpenes. For example, here you have the regular pattern of monoterpenes, but in our case, for example, this is for limonene. Okay, but in our case, the pattern is completely irregular. Okay, this was important for us. These results were at first published in this journal together with the morphoanatomy of these plants. We were interested in isolate this compound. We isolate it after obtained by simple chemical modifications, obtain different compounds in pure state. For example, the corresponding from the acetate, the corresponding alcohol, the ketone, the phenol, the epoxide. Okay, we studied the molecular properties of every one of them, and also we perform a spectroscopic study through a battery of spectroscopical techniques. We published these results in together with computational chemistry in the Journal of Molecular Structure. But what about the possibility to have allosteric activity? So not only the essential oil, but also the compounds, the pure compounds and extract were submitted to analysis against snake venom. Here we have the bottom of the pores. We obtain desiccated venom, that is yellow venom. Okay, and we obtain also the essential oil and extract obtained through maceration in these solvents, also extract of soft-select apparatus in this solvent. And we apply different techniques or assays employed to confirm the in vitro activity, bioactivity, alexitheric activity. So we perform proteic profile modification through the following the activity through electrophoresis. We apply proteolytic activity inhibition, also following through electrophoresis. We apply also indirect hemolytic activity, procoagulant activity inhibition. Okay, I have no time to describe every one of them, but for example, here you have the indirect hemolytic activity inhibition assay, where you have different halos in a plate with medium composed of agar blood medium. Okay, here you have different halos. Okay. The halo is produced by the hemolytic action of the venom. When you incubate your compound or your extract with the venom, and the venom is active, and the compound or extract is active neutralizing the effect of the venom, you cannot observe the halo. Here, for example, here you have the hole, but you have no halo because the venom was neutralized by the compound present here or the extract. Okay, when bigger your halo, less active is your compound or your extracts. At the end, we also perform this work a structure activity study. Okay, here we have a summary of the activity. Here you have the essential oil, the pure compounds, the extract in ethane as ethanol and water, also the extract of substrate. Okay, we perform all the tests, and the most active sample was this ketone derivative ortho ketone. Okay, this was the irregular ketone that by itself inhibited 50% inhibited the hemolysis by 50%, and also inhibited the procoagulant activity by 20.4%. Also here is a very good result, but this also inhibited the proteolysis, okay, inhibited or modified the protein profile of the venom. So this was the most active sample of all the evaluated ones. Here is the publication. We recently published these results in this journal. Okay, after we performed this work with Baccharis trimera, we asked about why, if is it possible to find other species of Baccharis genus with these properties of inhibiting the effects of the venom. So we selected 14 Baccharis species, including, for example, male and female individuals when possible. We extract them through volatile and non-volatile extracts, for example, using maceration, using sucklet apparatus, and also through using the essential oil by steam distillation, obtained by steam distillation. And we apply has a screening, okay, electrophoresis has a primary indicator of electric activity. So if you have a profile of a snake venom profile modified by the action of your extract, it means that it's possible to have electric activity, okay? In that base, we obtain from these 14 species, we obtain 3 bioactive species, Baccharis articulata, Baccharis dracunculifolia, and Baccharis punctulata. With these species, we perform phytochemical studies, and also we confirm these results through in vitro assays. For example, proteolysis inhibition, hemolysis suppression, and coagulation interference. The same that I mentioned previously. Here you have a scheme of the different plants we used, and also from the 49 extracts we obtained. Okay, here are the numbers of the extracts. We analyze all of them, but the most important sample, the most important species was this one that is very related chemotaxon genetically to Baccharis trimera, that is named Baccharis articulata. Okay, this Baccharis articulata presented 3 extracts active against snake venom at in vitro condition. For example, here you have again the halos. Okay, here in number 1 you have the effect of an agar blood plate of the snake venom only, okay, the hemolysis. Here you have, for example, inhibition, almost complete inhibition of the hemolysis of the snake venom. Okay, we identified this as important and promising species for continuing our work, but subsequent work is needed to elucidate the electric compounds because we did not identify them. Okay, we published these results also recently. Here is a list of different plants evaluated against the snake's venoms. Okay, most of these plants have tradition of use against the venom. For example, this one, Aristolochia, or others, for example, this one, and others, okay? This is not my work, it's my lab's work, okay? All these plants have been evaluated by my lab's work. Here, for explaining it, sorry, I will present the result, for example, for these 3 species, okay? For this one, named Nectandra angustifolia, My lab's colleagues obtain extracts and obtain this ointment. Also, from this species named Croton. They also obtain ointments. And for this one, the climbing species, they obtain a thermosensitive gel. Okay, these all three ointment or gels were applied directly at in vivo condition. Okay, to in looking for activity at in vivo condition. Here you have is not only to fight against mortality, we have to fight beyond mortality, okay, against the local effects of the snake venom. Here you have a rat that is has necrosis by the local effect of the venom. Okay, it's not a problem of live or death, but the problem is the local effect. Here is the effect of the thermosensitive gel that was applied directly on the skin. You can see here the recovering of the red. Okay. At the end, I have to say that this statement by Professor Ladislav Rosenberg, that is the organizer of this meeting, he said that we live in a time of advanced medicine, yet we are also returning to our roots to the ancestral wisdom that has guided health for generations. This is also true for electric plants. We need to continue our research on plants used by the indigenous people to treat the snake bite envenoming, and also for having a more clear picture about the activity of the plant's compounds against the snake venom. Okay, this is the list of reference that we used for doing this presentation. At the end, I will present my co-author, Professor Ana Maria Torres from Argentina. She is responsible and is behind the bioassays. Okay, Professor Cesar Catalan, also from Argentina. He is collaborates with us in the chemical transformation of the compounds. Okay, Professor De La Casa from Uruguay is the coordinator of the project. That is me. Okay, that is my email. You can write to me. You do not hesitate. If you have any doubt, you can write to me. Here is my ORCID profile where you can see my research. Okay. Again, I want to thank you to the organizing committee for inviting me and also to you for your kindly attention. Thank you.